Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello students, in this video we'll find the expression for the time period of a satellite which is very close to the Earth's surface. Students, let us discuss about the time period of a satellite which is very close to surface of Earth. Time period of a satellite which is very close to the surface of the Earth. Suppose that this is the Earth, its radius is r and the satellite is very close, so that closeness makes h value 0. In that situation we have to find the time period of this satellite, how much time it will take to complete the rotation, to move once around that planet, how much time it will take. The time period expression was 2 pi divided under root of gm r to the power 3 by 2 was the relation. On the root of gm, because we know that gh is under root gm over r square, so this gm can be written as gh r square. If I substitute this over here, gm as this here, what I'll get? I'll have 2 pi. This is gh r square, the root is there also, and r to the power 3 by 2. So what I'm getting is t equals to 2 pi r to the power 3 by 2, that is r and r root, divided by gh, and root and r square root is r, 1 r will cancel, so this is 2 pi r over gh, this one gh and root. This is very important relation that we are getting, that 2 pi r over gh under root. Now if I substitute the value of gh, this is gh under root, gh right here, this is the formula. Now for very close, h is 0, that means this r, which is r plus h, will tend to r, and the gh, which is gm over r square, r plus h the whole square, will become gm over r square, which tends to g. That means for very close rotation, this will become 2 pi, the small r will become capital R, this gh will become g. And it is very interesting to note that for very close rotation of the satellite, the time period is coming out to be 2 pi under root of r over g. 2 is a constant, pi is a constant, and r is 6400 kilometer, which is this much of meter, divided by g, which is 9.8 meter per second square. Putting all those values together, I'll get time in seconds, and that seconds to be converted into minutes. Then I'll finally get 84.6 minutes. That you have to remember for very close rotation of satellite, because that is the constant. This time period is constant. That depends on the radius of the Earth. That depends on the g. So this is the answer. So very close rotation. The time period is 84.6 minutes. Okay. Thank you.